Force, acceleration, and friction. True or false, objects move only when a force is exerted. Now, this is a tricky one. I encourage you to study this one. This one is actually false. It's false because I could think of one example where it's not true. Can you think of an example where a force is not exerted and an object is still moving? I want you to think about, what about space? What about on an ice rink? Can you have a rock going through space with no one pushing it, but it's still moving? Yeah. So let me put that example so that you guys can see it. Rock moving through space. And there's no forces acting on that rock, but it's still moving because it started moving. And this is the whole, okay, it's inertia. It's already moving, so it doesn't take any forces to make it keep moving. It wants to keep moving. Okay. True or false, the acceleration of an object is directly proportional to the net force acting on it. Acceleration compared to net force. Now, this directly proportional, this is probably the first time in your life you've ever heard this phrase. So let me just make sure that you know what it means. It means that as one goes up, the other goes up. And as the other goes down, the other will go down. So in order to see this, we should have a couple comparisons. And we should know the equations for acceleration and the equation for net force. So acceleration is equal to force divided by mass. And we can say that the force is equal to mass times acceleration. So what we want to focus on is, what is the relationship between the acceleration and the force? So some of you might see it right away. Some of you may have examples in your mind, but let's say I started out with a force of 10, a mass of, let's make it up and call it 1 to keep things easy, right? We're not focusing on the mass. Let's just keep it basic, 1. And an acceleration of, well, if it's mass times acceleration, 1 times what gives me 10? It would have to be 10. Okay. So let's say this is how I'm starting. I'm going to start with that. I'm going to say, and then increase one of them. Let's say I increase acceleration. Then I'm going to say, I have this again, except I'm going to remove, I don't know force yet, but I'm going to say acceleration jumped up to 20. I doubled it. Okay. Well, in order to find force, I have to do mass times acceleration. So mass is 1, acceleration is 20, so force is 20. So now let's look at what actually happened here. We would say, okay, so as acceleration increased, my net force, and whatever word you put here is going to tell you if it's directly proportional or indirectly proportional. If you have a word that goes increase and then increase, that is direct. Direct because it's the same thing. If you went from increase to decrease, let's say if I made this 20 and the force dropped to like 5 or 4 or 1, and the force went down, well, then now we're talking about the opposite. We're talking about inverse. But this is direct because it's increase, increase. And so I would say this is a true statement. Okay. The acceleration produced by a net force on an object is directly proportional to magnitude of net force in the same direction as net force, inversely proportional to mass, all of the above. Now, I don't know about you, but whenever I see an all the above answer, I'm tempted to answer it. I'm tempted to choose it. So what I need to remember is, if I identify the first one as true, I need to make sure that I need to check to see if other ones are true. So this is, again, just like the one before, we're talking about acceleration compared to net force. Okay, well, what do we find about acceleration and net force? Well, we found that acceleration is directly proportional to net force. Okay, so magnitude just means the number compared to direction. So I'm going to say this is true, okay? In the same direction of net force, yes, of course. I mean, remember, if you have net force going to the right, you have acceleration going to the right. True. So again, I want to say D, all the above, but I'm a careful test taker and I'm going to make sure that C is also true. Inversely proportional to the mass. Okay, interesting. Remember, inverse means the opposite of what we were just talking about. So let's say, let's test this. I start with this, and now I'm going to say, okay, now my acceleration, because I don't want to worry about acceleration. Acceleration is 1, and mass is 10. And then I'm going to increase mass. Excuse me, I need to go back on that. This question is asking you to compare acceleration compared to mass. So I want to keep acceleration. And so I'm going to make up a different acceleration, and I'm going to call that the mass is 10 and acceleration is 10. Who cares? I'm just making it up. But that means that the force is going to be 100. Okay, then I'm going to directly proportional to the mass. I'm going to increase the mass. I'm going to see what happens to acceleration. So I'm going to take this. And so I was a little confused about this question, so I'm just going to reword it in my mind. Compare acceleration and mass. Okay. And this is the type of thing that if you're confused about the wording of the question, you could always ask, and if we can answer it, we will answer it for you. Okay, so if I increase mass, so mass goes up to 20. It's not asking me to compare force, so I need to keep force the same. I need to keep it the same. No ifs, ands, or buts. So acceleration is now, I'm going to delete it because I don't know what it is yet. So the equation is force equals mass times acceleration. So mass times 20 times what is going to give me 100? Well, 20 times 5 is going to give me 100. So I could say, so as mass increased, my acceleration, and then whatever word you put here is going to answer this question. So as mass went up, now if you were to say increase, it would be direct. If you were to say decrease, meaning going the opposite direction, it'd be inverse, right? Opposite, inverse. But do you see that mass went from 10 to 20, increased, acceleration went from 10 to 5, decreased. So I would say decrease, and now I have convinced you that yes, it is inversely proportional. That is what inversely proportional means. The answer is all the above. If the net force acting on a cart doubles, what happens to the cart's acceleration? So now we're asking you to compare net force again and acceleration. Force and acceleration again. Well, if the force doubles, remember that we said that this was directly proportional. So again, let's think of an example. Now, what's different about this is not just asking increase, decrease. It's asking about like how much does it increase or decrease? I need numbers now. So I put, the same one. I just made up numbers. That force is 100, mass is 10, acceleration is 10, because 10 times 10 is 100. So I double the force. I'm going to need to take this. I'm going to need to copy paste it. And I need to double the force. So this now needs to be 200. And it says compared against acceleration. So the mass needs to stay the same. The acceleration is what is going to change. Well, since it's mass times acceleration, 10 times what gives me 200? Well, it needs to be 20. And so what happened to my acceleration? It went from 10 to 20. So it also doubled. And that is what, again, at least right now, with these simple equations, what directly proportional means. A 10 Newton force and a 30 Newton force act on the object in opposite directions. What is the net force on the object? So the net force means take all the forces together, add them together. And the fact that they're talking about opposite directions, I know that I'm going to be subtracting them. So again, they're not working together, they're working against each other. So subtracting them is 20. And they don't tell me a direction. They don't, nowhere in the question or answer do they tell me directions. So I'm not going to worry about that. Positive 20, negative 20, I don't know. If you push with 30 newtons on a 3 kilogram box, and there are no opposing forces, what is the acceleration? Well, looking back up to my equations, I get that acceleration is equal to force over mass. And let's see what they tell me. That, well, this 30 newtons, well, what is that? Well, that newtons is a unit of force. And I have 3 kilograms. Well, kilogram is a unit of mass. And so I have acceleration equals what? Okay, well, I'm going to plug in that on top I have 30, and on bottom I have 3. And so 30 over 3 equals 10. Now what's the units for acceleration? Meters per second squared. And that is my answer. Okay. A 50 kilogram block of cement is pulled upward, not sideways, with a force of 600 newtons. What is its acceleration? Well, the best thing for me is to see this in a diagram. So it's a 50 kilogram block of cement, and we're assuming, we're dealing with this cement on Earth, it's on a surface, and now it's being pulled upward with a force of 600 newtons. So let's draw that force. It goes up with the F that is applied is equal to 600 newtons. Now, can I compare 600 newtons to 50 kilograms? No, I can't, because they're totally different things. I can't say, oh, one is more than the other. No, it's like comparing apples and oranges. I need to be able to compare 600 newtons to another amount of newtons. And if we're going to call this a free body diagram, well, then we better make sure that we have gravity working on this too. So what is the gravity on this object? Well, gravity is mass and acceleration, and acceleration on Earth is 10. So I have the weight is equal to 500 newtons. And so now I have its mass here, and I have 2 different forces. So I can say a couple things. I can say that the net force is equal to positive, so the upward force is positive, so 600, minus the downward force, which is 500. So the net force is 100 newtons. I could say that the mass is 50, and I could say that the acceleration is in question. But again, the acceleration is just force over mass. So I know that the acceleration is force over the other one divided by mass. And so the acceleration is equal to the net force, which is 100, divided by 50. And so the acceleration is equal to 2. And the units is meters per second squared. Okay. I would say 2 meters per second squared. If someone were to mess up on this one, my guess is that they did not take into account the net force, meaning the force pulling down. And that is that question. Is that done? Okay, one more. A 50-kilogram block of cement is pulled to the right with a force of 600 newtons at a constant velocity of 3 meters per second. What is the force of friction? Now, I was about to go ahead and draw the diagram, but again, we would have a box on a surface not being pulled up or down by anything extra, so we would have gravity and normal force, right? And then it's saying it's being pulled to the right, so it'd have to have applied force to the right. But then it says, constant velocity. That is going to trigger in my head equilibrium. And so equilibrium means that the forces are balanced. And so if it's at a constant velocity, and I don't even care what the constant velocity is, but I know that it has a force to the right of 600. If the forces are balanced, I will say it's 600 newtons to the left. It matches it and works in the opposite direction. And now your forces are balanced. Do we expect you to say left? No, not necessarily. It's just asking what is the force of friction. But to the left is even more specific.